Today, I'll be speaking about feature stores in practice. And by the end of this talk, we'll train an end-to-end model using a feature store. We'll define our transformations. We'll build a training set. We'll serve features to a trained model, just so you can really see and feel the end-to-end workflow. Everything that I'll show will be using open source Featureform by design, so you can go ahead and do it yourself. I was kind of debating if I should make this follow along. The only problem with that is that I run a big Terraform script that kind of deploys all the infrastructure I need, and it just seemed like it might be a bit of a headache to get everyone to do that. So rather, I decided that I will run through this myself. Afterwards, I will send out a GitHub repo for anyone who wants to do this themselves, follow along, and iterate on it. Obviously, at any point in time, if you have any questions, you can always reach out to me. My email is really easy. I'm just Simba at Featureform. Featureform is open source. We have a GitHub repository, and we have a community, like a Slack channel you can join if you have any other questions. Awesome. So let's get started. So I'm Simba. I'm probably a need for a new headshot. I'm the founder and CEO here at Featureform. Featureform is the virtual feature store company. Going a little bit back, I started my career as a software engineer, much more focused on distributed systems. I really started to get into ML. I kind of had an affinity towards, call it fuzzy problems where there is no obvious right answer. So I really got into things like distributed systems and recommender systems. At my last company, we built a recommender system that powered about over 100 million monthly active users. And we were doing things like predicting churn, predicting subscriptions, and literally just personalizing experiences. So that was a lot of data. And at that time, we were using embeddings. We were doing all kinds of stuff that was relatively, especially at the time, more cutting edge. And almost all of the infrastructure that we had to build ourselves, because nothing really existed off the shelf we could use. And this is before the term MLOps really even existed. So we didn't call it MLOps. We just called it, I don't even know if we really had a name for it, just our infrastructure. And one thing in particular we built that became, what I saw as the most core piece of our platform, we called it our data platform. But nowadays, it would be called a feature store. And Featureform was kind of built off of the learnings there. We eventually open sourced it. And nowadays, I'm full-time building the company around Featureform. Awesome. Here's the agenda today. So we're going to start by just answering the question, what is a feature store? It's funny, feature stores have kind of been around since the early days of MLOps, but I bet you if I ask every person in this call what's a feature store, we'll get a different answer from everyone. So I'm going to really try to break down why people build feature stores, kind of focus on first principles, and less about just, again, vague marketing nonsense, and much more on like, why do people build these things in-house? Why have they been built over time, and why are now vendors start building them? As I go through that, I will show how in practice what ended up happening is there are these three separate architectures, almost three separate products that all call themselves feature stores. And I'm going to define those three. I'll define what they do well, what the differences are between them, and I'll give examples because there are a handful of different feature store products. I want to show you how they're grouped, what they do, and how they differ. Finally, the meat of the talk is going to be the workshop. In the workshop, I'll begin by talking about the deployment and configuration, pretty much like what I've deployed. Again, I decided for this one, it would be a little bit tough to do as a follow along. So I'm going to send a repo afterwards where you can, if you want, run a Terraform script and actually go through this yourself. We're going to build out some transformations. We're going to use Databricks, so Spark. We'll actually use Redis as our online store, and I'll get into what that means. We'll train a model. We'll just be a very simple XGBoost model on on the training sets that we build using Featureform. And then finally, we will deploy features and serve features to the trained model. So you can really see, again, how it would feel to use Featureform on both ends. By the end of this talk, I want everyone to really understand what the feature store is, what the different types are, and beyond the hype, beyond all the like marketing nonsense, what is this thing? Do you need it? And if you need it, how would you go about implementing it? Like I said earlier, if you have any questions, please feel free to just put them in chat. I have lots of natural breaks throughout the talk that I will use to answer your questions. So please feel free to do that. What is a feature store? Start with the basics. Let's actually start even more basic. What is a feature? So it's funny because the term feature is so overloaded. You know, you can think of a feature as like a product feature, or you can think of a feature as a model feature. It can cause some confusion what a feature store is. A feature in this context, in the machine learning context, is just an input to a model. That's it. So a model is this thing. It could be a black box. It could be a little more open that takes inputs or signals from the data, makes a prediction. During training, you can compare a prediction to, in supervised training, you can compare that prediction to a label and use that to adjust the model. That's what training is. So these are the three components: features, labels, predictions. A label mixed with a set of features makes up a training set. So these are all the components that make up kind of the abstractions of a feature store. Some examples of features. Let's say you're Spotify. You're making a recommender system. One of your features might be a user's favorite song in the last 30 days. Let's say you are building a model to decide how much inventory to send to a store. You might set up a store's top selling item in the winter as a feature, or the average price of all items in the catalog as a feature. All these things are features. The whole point of features is their signal. Like you have raw data, you build signal out of them, and you give it to your model. And in practice, as data scientists, what I found, at least when I was building, and we work with a lot of different companies from small startups to very, very large enterprises. And time again, we see that most of the iteration, most of the value, most of the ways to make your model perform better comes from the data. And really what that means is it comes from taking your data and getting better signal out of it, which is really just feature engineering. So how does it look in practice? Well, you have data scientists. Maybe you have one, maybe you have a team, maybe you have many, many teams. For working in notebooks, maybe some shell scripts here and there. For interacting with data, for coming up with ideas. And they're taking the data, they're playing around the data, trying to understand it, analyzing it, coming up with signals, features that they use to build training sets and train models. So this is kind of how the iteration looks. Most of the time is actually spent, and most of the focus is really spent on coming up with signal. That's really where you can take your domain knowledge and really apply it. The thing with models, especially more complicated models, is they're kind of black boxes. So it's a little bit more by feel. There's hyperparameter tuning, but a lot of that stuff isn't very, it's more by feel and it's less by intuition, where feature engineering, you can really intuitively come up with good features to make your model perform better. Who here has run into the problem where they, in their notebook, maybe on a sample of data, they've come up with a really interesting training set, a really interesting feature for their model. But now, assuming that model is interactive, like a recommender system or a fraud system, etc., you have to deploy that feature, which means it has to update according to new data. It needs to be production ready. It can't go down. It might need to be run on the full data set, maybe on something like Spark. And the actual step of getting your features in production can be a huge gap. It could be this chasm that's almost uncrossable at some companies. And many, many companies, they throw it over the wall. They're kind of like, oh yeah, like I'm a data scientist. I built this cool feature. Now I have to give it to the data engineering team and hope that one day they figure out how to get in production. The data engineering team is like, look at this ridiculous notebook this data scientist sent me. I have to somehow try to turn this into production grade code, and everyone's angry. So this is kind of I'm going to reveal some of the hidden truths of data science that we all know to be true, but we don't talk about enough. This is one of them. In practice, we have this wall, this fence between our experimentation, building in notebooks, kind of coming up with ideas, and actually getting those features in production. At some companies I've talked to, some large tech companies that you would assume like kind of are super cutting edge at this stuff, I've heard timelines like 6 months to get a feature from experiment to production. Especially when you get to like regulated industries, and there's like not even just like how do I literally write this thing for production, but also how do I get checked off in all these places. It can take a very, very long time to get a feature in production. And the workflow is just ad hoc. Like literally, sometimes people just email or Slack people notebooks and say, hey, this is it. Like, can you please get this in production? And that's it. And then they just communicate that way. So production is a very different beast. And the way the data science workflow is set up isn't really oriented towards production. And for good reason. Unlike software engineering, data science is very experimental, it's very iterative. It would be very painful and very wasteful to write every experiment as if it's production grade code. That doesn't make sense. I don't think that's a solution. But I do think that there needs to be something that better fills the gaps between this. That's at least a lot of what we built was more like, hey, we want to be able to experiment really quickly. We don't want to get away with that. But when something's ready, we don't want it to be this like impossible leap to get into production. That's really painful, very error prone, requires rewriting things, sometimes literally from Python to Java. This like crazy stuff happens to get things in production. Let's talk about why. Let's talk about the anatomy of a production feature. There are 3 types of features. There are streaming features, there are batch features, and there are on-demand features. Let's start with batch features because they're the simplest. Batch features typically run on some batch processor. Spark and Snowflake are probably the most common. They typically run on a schedule because data does change, but they're not running constantly. They might run every 24 hours, they might run every week, they might run every hour, kind of depends on the data set. The benefit here of using batch features, like why we use batch features, is in practice, it looks the closest to what the experimentation is. So it's the easiest, and it's the most like straightforward. The con is the features tend to be some amount of stale. If you're running every 24 hours, then that feature's value isn't changing for 24 hours. Now, why even run it this way at all? Why are we kind of pre-processing features? Well, the answer is in ML, we deal with such large data sets. And if you're doing something like a recommender system, you have millions, hundreds, over 100 million users. There is no way that if someone opens a Spotify home screen, that I could take all of the listens they've had and process all my features at that point in time. It would take way too long. It would be extremely expensive. In practice, what we do is we will just pre-process a lot of these features when they can be pre-processed. For features that don't change very often, doing batch is fine. Like for example, if I do a user's favorite song in the last 30 days, if I run that every 24 hours, it will be pretty good. It won't be perfect. It will be a little stale, but it's not like that feature is changing every 5 minutes. So it won't be it will be a very good feature. It'll be very close to accurate, and the simplicity of maintenance can be very worthwhile. So there's kind of a balancing act. On the other side, there's streaming features. Streaming features are features that are processed constantly. So every time an event comes in, we process the feature, or rather update the feature with the new event. So for example, if we have a feature which is the last 5 songs the user listened to, that's changing all the time. It would be completely useless to do that in batch every 24 hours because it would just not have the context. So those features, the freshness is extremely important to make the feature work. In that case, streaming is the only way. Now, the problem with streaming is it's just much more complicated. There's way more gotchas. If you've ever dealt with stream processing before, I don't really have to tell you. If you haven't, you're lucky, and trust me, it sucks. It's really tough. There are benefits, and it is needed for certain features, but it's not. I would not recommend that everything be a streaming feature. It's not really worthwhile. Finally, there's a certain type of feature which can't be pre-processed. For example, let's say I am building let's call it a spam detection for YouTube comments. Well, I can't pre-process the features in relation to the comment because it doesn't really make sense. The comment happens at request time. So there's some times where the data comes with their request. Now, we still process that data, so they are still features, but they kind of look different in the sense that we're not pre-processing them. They don't live in S3 in the same way. They're kind of happening on the fly. These are the 3 types of features. In practice, we'll take our notebooks that have these experiments on samples of data that are really nice and easy and clean, and we need to then evolve them into this production system that sort of looks like this. So that's the leap here. Now, I assume most of you have models in production. So it's like you've done this, you've pulled this off somehow. But I bet you, even though your model's in production, this might look a little familiar to you. I know it's early in the event, and I just took a red eye. I've been flying for the last like 6 hours, so thought I would start it with a lot of memes this morning. This look familiar? Untitled 128, the iPi notebook, DF final real, feature table v7. Having your ad hoc Spark submits. And of course, we all document our features, right? Like no one here would not document their features. That would be awful. We would never do that. As data scientists, we're quite organized. We know how important data is. We would never not document our features. So I have a few more memes. I was just reading a story from someone who went on vacation for a couple weeks, came back and saw Vertable underscore v2. No context. They have no idea who built it. They don't know what the difference is. They just came back one day and there's now feature table v2. Now, what do you do about it? You just look at it and you just, I don't know. It's the reality of data science in enterprise and larger company settings nowadays. This is just how we do things. We don't have a process. Software engineering has a process. That process does not work for data science because data science has a lot more trial and error. It's a lot more iterative. It's a lot more guessing. It's a lot more. It's more like a science than a engineering. And for that reason, we kind of take the approach of being more experimental. But there has to be something in between. And I don't think as an industry we've really come to the conclusion. And that's part of what I aim to solve with Featureform. There's a question someone asked earlier I'm going to come back to before I go forward, which is what's the difference between an on-demand feature and a streaming feature? So think the difference between an on-demand feature and a streaming feature is a streaming feature is pre-processed. So let's say you're a user and the feature is the last 5 items you listen to. So in practice, or let's make it a little more complicated. Let's say it's the average price of the last 10 items you bought on Amazon. That feature is constantly changing, right? Every time you buy something, it changes. And it might change dramatically based on every single buy. But the feature is pre-processed. Like the feature can continuously be updated as data comes in. You see how the inference request comes on the right side? When a user makes an inference request to the model goes and grabs the features. That feature can already be created and pre-processed, and it's being constantly updated and it's very fresh based on a stream. On the other hand, there are features like let's say you take the sentiment of a comment a user made. So a user makes an inference, or a user posts a comment. You want to see if it's spam, and one of the things you do is you take forgot the word, but you take something of the content, the comment that they made. That happens at request time. You can't pre-process that. So that has to happen on demand. That's like real time, where it's really happening at the time of the request. Whereas streaming, it's like near real time in the sense of it's being updated constantly. It's very fresh, but it doesn't have to be up to like the exact moment. I hate the word real time because if you talk to different types of engineers who work in different industries, they have a very different definition for real time. But yeah, streaming, I think even like something like Kafka and Flink, they would call themselves like near real time because there is a delay. It's not truly real time, but it's much more fresh than like batch. And for machine learning context, that's pretty much real time. If it's like if you're building something with like hardware and you're building a space system, it's not real time. So it really depends on the context. Okay, I want to really highlight a few things that are not problems, because these are things that a lot of feature stores aim to solve. And I think it causes a lot of confusion because people are like, oh, I don't have this problem. One is that Redis, Spark, etc. aren't good enough. Like, don't get me wrong. Everyone has their qualms with Spark. Everyone has their qualms with all these different tools. But they're good enough. And in practice, we don't need a better Spark. And if we did need a better Spark, we wouldn't trust some startup to build a better Spark. We just hope that Databricks continues to build a better Spark. We want everything to be streaming. A lot of feature stores have kind of put their hat on top of real-time everything. Everything has to be streaming. Some features benefit from being streaming. Streaming features tend to make up like the average that I see based on the people that we talk to, our customers, our users, prospects, is like about 5% of features tend to be streaming. Those 5% have to be streaming. Like well and truly, like it adds a ton of value. And those 5% make up for a lot of headaches. That said, it's not really a benefit of making the other 95% streaming. In fact, it's a con because you have to rewrite everything. Streaming comes with a lot of headaches. There's a lot of overhead. There's a lot of complexity. And in practice, if something can be batched and scheduled, it should just be batched and scheduled. Finally, everything I talked about was about the creation of features. It's that feature engineering process. Like you're building features, you're deploying features. Some people have taken feature store very literally to mean, oh yeah, it's a place where you store features. It helps. I don't think it really solves the problem. It helps for specific things, which I'll talk about, but really it's if you remove the feature from its lineage, from the how it's created, and you treat it like an artifact, I don't think it's as valuable. In practice, it doesn't really solve the problem here, which is like if I give you a place where you can store all of your final features, it's not going to solve this problem, right? All of this stuff would be completely unaffected, more or less, with that. All of us would be more or less unaffected if everything was streaming. In fact, it might even be worse. None of this is necessarily a Spark isn't fast enough or good enough problem. It's more of a workflow problem. So the problems that we see are actually have very little to do with these sorts of things, even though a lot of feature stores have focused on these problems. And I think it adds a lot of confusion. And again, part of what I'm trying to do here is remove some of the confusion, give you an opinion that we've seen work, that I've seen work for myself, I've seen work for our clients, and show you how it looks in practice. Okay, so I've talked a lot about vague, like what does Featureform and feature stores do? Let me actually talk about the details. So Featureform, we call ourselves a virtual feature store. The problems that we aim to solve, the way we work really, is we think of ourselves as this layer above your infrastructure. So we're an orchestrator. We're literally orchestrating the Spark jobs and putting things to Redis. We're doing point-in-time correctness. We're doing backfill. We're doing all the stuff that you've dealt with if you've really built features in production. On top of that, we add a single source of truth, a definition language where you can define your features, define the transformations, define the labels, define the training sets. All that stuff is defined. All of it's searchable. All of it's reusable. So you can collaborate on it. You can see tags, you can see groups, you can see lineage. Monitoring and alerting comes built in because since we're serving the features both for training and for inference, we can look for drift. We can see how we understand. We're not just like a data orchestrator. We really understand, and we're built entirely around the feature process because we know it. That's what it's built for from the ground up. And from your perspective as a data scientist, you're working in an API and you're still writing your own SQL, you're still writing PySpark, you're still working in a notebook, it's still Python based. There's a dashboard too, so you can look at some data, you can search things, you get a lot of value from the dashboard too. But we're not trying to break the workflow in the sense of like, we don't think the problem is that PySpark is wrong and that there needs to be a new language. That's really not what we want to do. More what we want to do is build some sort of framework to define, manage, deploy your ML features. The name Featureform, for those of you who maybe have any DevOps background, comes from Terraform. So literally when I came up with Featureform, the idea I had in my head was, I wish I had Terraform for features. And then because I'm so creative, I called it Featureform. Now, and yeah, so the way the framework works is that there's, you work in, your logic is still in SQL, it's still in PySpark, but the framework, the definition language is Featureform. So you're kind of putting things into our scaffolding. And then by doing that, we can deploy it, we can run on Spark, we can run on Redis, we can build real-time features, we can build on-demand features, we can build streaming features, we can build batch, all that stuff gets built in. And it runs anywhere. That's where the virtual comes in. You use Spark in some places, Snowflake in others. If you're a GCP shop or an Azure shop or you're on-prem, doesn't really matter. The same way Terraform doesn't care, Featureform was built from the ground up to be agnostic to the infrastructure. We just have these different abstractions and you just plug in whatever you use. And you still use the same code. So there's a question about edge and robotics. We actually do have a few customers in the IoT space, but so the training tends to be on centralized data. So for this really to work, the data has to be centralized. Now you might deploy the models on edge devices and you might serve on edge devices. That's what they do. That works. But Featureform was designed with the idea of having like a data lake. If that doesn't exist or you're doing some form of federated learning, it doesn't really fit into how we do things. That's a great question. Okay, everything I've talked about might sound a little different from what you've heard before, right? Like that's not how you've been talked about or features have been described to you, or if you've used them, maybe that's not exactly what you've seen. The reason for that is pretty interesting. So one of the most common architectures for feature stores, we call them the literal feature store. Some people call them traditional feature stores. Some people just call them feature stores. So in a literal feature store, this is what Feast does, this is what Vertex does, this is what Databricks' feature store does, it's what pretty much every cloud service and Feast does. The reason for that is everyone just copied Feast. And the reason Feast looks like it does is kind of interesting. It's actually it's kind of a Conway's Law thing. In practice, Feast internally does not look like Feast. It's part of a bigger project. But everyone just kind of copied Feast at the time, and they've kind of stuck with our architecture. So the way a literal feature store works is you as a data scientist are still building your features, you're still experimenting in your notebook. When you have to go deploy, you still have to deploy it. You have to give it to the data eng team. Pretty much nothing's fixed in that way. What is solved is that all of you have one source, like one database, almost like a cache for your features. And this cache has a specific architecture or specific, let's say, property where it can serve for training. So when you train a model, you have to have historical values of features. So as you write features, it maintains a log of old features. And it lets you serve for inference. Now, if your feature transformation pipelines are really dialed in, you're not really building new features, it's not really an iterative process anymore, you're just deploying and done, this can work really well. In practice, as you all know, if you're data scientists, a lot of what you're doing is building new features and iterating on features. And this actually gets in the way. It tries to lock down your transformation pipeline. And because they're disjointed, every time you change one, you have to change the other. And because you always have to change the transformations first, all the value prop from the literal feature store tends to kind of be washed out by how painful it is to iterate on features, get lineage, do like all the other things that you would need that we've talked about for transformations. Most companies internally, like if you look at Airbnb and Uber and even Gojek, which built Feast, they have something that looks like, we call it a physical feature store, some people call it a feature platform. In a physical feature store, the transformations are tied to the storage. In that way, you define your you don't define your features as like it's not an artifact, it's not like a table. The feature itself is the definition, it's the logic, it's the PySpark code or whatever that actually builds a feature. This is much more natural to the workflow. This is like, in my opinion, how these things should work. So I think that this is the correct way to do it. And this is why pretty much every major company that's had a ton of success with feature stores and have talked about them, like again, Airbnb, Uber, etc., they've built something that looks like this. But here's the problem. If you're a large company, you have a big team internally, and you're building and maintaining this, it makes a lot of sense. But if you're buying a vendor, if you're buying a third-party solution or bringing in an open source third-party solution, you now have to rewrite all of your features. You have to transform or rewrite all your transformations. It's just completely replacing. It's a very heavy thing. It's a very heavy piece of infrastructure. It's kind of on the same abstraction layer as like a Spark. So I think it's correct, but it's too heavy, which again brings up the idea of the virtual feature store. With the virtual feature store, the idea was, how if we took those concepts of the feature platform, the things that make a feature platform work really well, having lineage, having a definition language, having monitoring, alerting, having governance, having orchestration, all of that built in. But rather than us owning the compute and the storage and like really tuning that, we just let you plug in whatever you already use. And rather than coming up with our own language for defining features, you just still write PySpark, you still write SQL, all your logic's the same. So we've decided to become more lightweight, and in doing that, we're able to orchestrate and be what we call a virtual feature store. What's been interesting as of recent is in the last Gartner hype cycle, they cut the feature store category and renamed it a logical feature store. And if you look at the definition and what Gartner has, based on their conversations, come up with, it looks almost exactly like a virtual feature store. And it's funny because when we named the virtual feature store, we actually considered calling it the logical feature store. So a lot of people kind of in parallel have found that this is the right approach. And the reason it's the right approach is it gives all the value of like a full feature platform where a feature store doesn't. But it's very lightweight. It's really easy to plug in. And in Featureform's case, it's even open source. So you can actually use this with just in open source. Okay, I've just spent about half my time telling you all about what feature stores are, talking to you about Featureform. Like I said, I don't want you to leave this talk and be like, cool, I know all the value props of feature stores, but if someone was to go deep and ask me how it works and how it looks, I'd have no idea. So my goal, like I said, is to show you real code and to build a real project together. Like I said, everything I show, I will send afterwards, so you can actually follow along. So first, um, it's Featureform managed service, and how does it work inside a cloud? I'm actually going to answer this question right now. So the way Featureform works is it's because it's an orchestrator, because it's a virtual feature store. It sits, the open source version just sits on Kubernetes. So we're orchestrating out of Kubernetes. You can actually actually all of our customers are deployed in their cloud or on-prem. So that's kind of how it works. We actually don't have a managed, like a SaaS service yet, because in practice people don't want their data to leave their firewall, which we totally accept and agree with, and that's why we do things the way we do. So okay, I've deployed Featureform. What have I deployed? So what I've deployed is in Kubernetes, I've Helm installed Featureform. As well as Featureform, I've deployed a Databricks cluster. It's running on AWS. I've deployed Redis. And I've deployed S3. So Featureform is on a Kubernetes cluster in AWS. And then because Featureform doesn't do its own storage and it doesn't do its own transformations, you have to bring your providers, your plugins. And you can choose whatever you want. If you use Redis or Dynamo or both, it doesn't really matter because we're just orchestrating. If you use Spark or Snowflake or both or Postgres or whatever, Pandas even, we support all those. So that's what I've deployed so far. So I have Featureform is deployed in a Kubernetes cluster, and it is connected. I've configured it to be connected to Spark, Redis, and S3. If you follow our docs, it's very, very easy to do this, to deploy and configure it. But I pre-did it. Okay, so now that I've done that, so I have this notebook. Again, I'll send it after. It really goes into detail of how everything works and other stuff, but I just have this just to make sure everything's set up right. I'll have deployed Featureform, which makes sense. First thing I'm going to do is connect to my client. Now we have many different environments that we have set up, so I just set it up for this one. I'll run this. So now my client's set up. Everything in Featureform is versioned. All the transformations, all the files, all the features, all the training sets. Everything is versioned. You can set a version on everything. By default, we'll automatically generate a version. We also have this idea of a set run, which will kind of set a blanket version on everything. This is useful if you want every thing in a notebook to have the same version, almost like an experiment. So that's what I'm doing here. I'm creating my sandbox Simba version. So I'll run this. Like I said, I've already configured Databricks and Redis. So rather than me having to go set up my connection to Redis, set up my connection to Databricks, figure all that stuff out, because it's pre-configured, if I have access to it, all I have to do is ff.get Spark, ff.get Redis. I can just get all the infrastructure I need. So I'll do that. So I've already pre-configured a data frame. Sorry, not a data frame. I've pre-configured a source. So Featureform has the idea of data sets. There are two types of data sets. There are raw data sets, or primary or ever data sets, which are data sets that you just register a Featureform. We don't build them or create them. We just kind of read from them. It's like a read-only pointer. And so I have one called transactions. The variant, which is like the version, is called clean. Everything in Featureform can be interacted with as a data frame. So I can do client.data frame, variant clean, limit 1,000, and it will get 1,000 rows from that data frame. If I go to my sandbox, I can also go sorry, if I go to my dashboard, which I'll show you after actually, I can go and get into it there. I can always get pre-registered features. So if someone built a data set or a table or transformation that you want to use or build off of, you can always just do that. You can just do ff.get source, ff.get feature, ff.get training set. The whole idea is to have a centralized source of truth. All these things that you build, all these transformations, all these features, everything, now it's all centralized. So it's not across 400 different notebooks on different people's computers, and some of them are on SageMaker and some of them are on Databricks. All the data artifacts live in one place. They're managed in one place. They're monitored in one place. They're governed in one place. Again, I want to make sure I'm not going too fast. So if you have any questions, please drop them in chat and I'll make sure I answer them. So next, let's talk about building transformations. So in a transformation, in this case, we're literally writing PySpark code. So it's the exact same code you'd write with or without Featureform. The difference is that you are annotating it with Featureform. You're saying, hey, it's running on this Databricks thing I've set up. You are setting your inputs. You can set variants. You can set description. The description defaults to the PyDoc, and the name defaults to the name of the function. And again, everything I create can be run and applied as a data frame. There's a question, or I guess maybe a point of like ZenML plus Feast. So Feast, like I said, it's a literal feature store. It does not do transformations. It won't orchestrate your Spark. Think of what would happen if you were going to go and iterate on this feature. You were going to go and you're going to build different types of features, different versions of features, build different training sets off of them, make sure that you are, once they're ready, that you're putting them in production. ZenML isn't really focused as much on the data orchestration. It won't really orchestrate Spark in this way. It's not really what it's built for. We're very close to the ZenML team. We've considered even building that integration together. So it's not, they work, Featureform and ZenML work on very different levels of abstraction. ZenML is really focused on the full end-to-end, but they are really specifically focused on lots of the stuff around the model. Feast doesn't do transformations. So all the stuff I just showed you, PySpark, creating schedules with PySpark, handling streaming data, all the stuff there isn't really possible to do in Feast. Feast doesn't even have the idea of lineage. That's the key difference, is the way we think of Featureform. Featureform and Feast are arguably competitors, but the big difference is that one, Featureform orchestrates your transformations from end to end. So you get the lineage, everything becomes reusable, and it has all the other value props you'd expect from Feast. Does Featureform work with AWS Glue Spark? Yes. Featureform works with Databricks, CMR, or just any Spark. We have those three. So we have specific built-in to take full advantage of Databricks, take full advantage of EMR, and we just have a generic Spark provider too. Another thing that's really common, if you've ever dealt with, I guess, real world code, is, another thing I should probably share before that is everything you build, like I said, it's searchable. You can see it in the dashboard. You can see how it's defined. You can preview it. You can get analytics on it. You can get monitoring on it. All that stuff can be set up in Featureform. Tags, owners, all that governance can all be set up as well. For a more complicated feature, let's say I have a feature where I want to know the mean or the average transaction amount. So the average a user spent in their last 30 transactions. So how would I do that? Well, again, I just can use PySpark to set up a window, and I can get that window to be in the last 30. I can create a rolling mean, so that it maintains a rolling average. And what that will do is it will give you the mean at every point in time. So when you're building a training set and you have a label, we will automatically, and I'll talk about how the labels work, and I'll just show you how it will work together. You can grab a label, say, hey, this label, this thing happened on Monday. What was the feature's value on Monday? And Featureform will automatically build a training set, zip it together, and make sure that the label is joined with the features at those points in time. So even really complicated transformations like this are just very simple to do with Featureform. And again, everything can be used as a data frame. Finally, we can define our features and our labels. We have this idea of an entity. An entity is something, it's like a primary key. It's a little different, but you can think of it like a primary key. So the primary key of all these features and this label is user. So the label is fraud, which is based on the transaction. I have the features average transaction, balance, which is a user's balance, and percent. Percent balance is how much of the transaction, or take the transaction amount. So if I'm buying something that's $1,000 and my balance in my bank account is 10,000, then percent would be 10%. Everything so you would define these things, you define the columns, you could specify the type if you want, you can specify an inference store if you want. So if you're going to deploy this and use in production, you can specify that, hey, I want to maintain the most recent values in Redis. So you have the historical features, which will be built in training sets, and you have a cache of the most recent values for low latency serving in production. And to a question that was asked about, does Featureform help feature definition be consistent across, typically when people ask that, they mean across offline and training and online. And the answer is yes. In fact, in this example I'm showing you, I'm building a training set and I'm maintaining up-to-date cache. The screen share is not showing my notebook. It's strange. Let me try. I think I was able to get it work if I shared back and forth a few times. In this situation, I'm defining and building my training set. So my training set is called fraud. I'm setting the label as user.isFraud. I'm setting the features. And I apply it. When I apply it, it creates those features, it creates the label, and it creates the training set. I can use those features. I can use that training set. I can just get it. Client.training set. I get it by name. I can use it as a data frame. I can also stream it in mini batches if you have a very, very large training set and you don't have Spark where you can distribute the data frame. You can always stream in mini batches. And then I can train a model. And training a model is really simple. I just have this training set. It's a data frame. So I can use that data frame very similarly, and you can get that data frame both in pandas. In this case, I get it in pandas. You can get it in as a Spark data frame, so you can train in a Databricks environment. You can kind of do it any way you want. And when you're training as a data scientist, it's exactly the same. I'm just giving you the training set. The difference is that everything you've defined has been defined using Featureform, and Featureform will guarantee that every feature you built is automatically usable in production, and that every feature, every training set you built has lineage, so you never have a situation where you have a training set and you don't remember how you built it, or you can't reproduce it because it's just too many notebooks, too many cells were run in too specific an order to reproduce it. You get full lineage automatically. There's a question, can you use multiple primary keys for a feature? Currently, no. It's something that we're working on, but you can serve multiple primary keys at once. So you can serve features from multiple entities at once. But we're in the midst of getting the multi-entity join to work. That's a great question. How about inference? So I have this feature. And the feature I created, that percent feature, is the transaction amount divided by the balance. Now, the balance I have in the feature store, I defined it earlier. But the transaction amount, I can't have that in, I only get that at request time. Like when the user, this is a fraud data set. So when the user tries to buy something, that's when I get transaction amount. So when I trained my model, I was able to use the historical transaction amounts. But in production, I need to actually build that feature as an on-demand feature. And it's very simple to do. All you do is you define an on-demand feature, which looks like a Python function. In practice, it's kind of like a stored procedure. And this thing can be used exactly as you'd use any other feature. So and it's also stored, you can set it as a variant. It's kind of stored next to the other features. It's monitored in the same ways. Again, there's one pane of glass to look at, manage, and use all of your features with Featureform. And how does that look in practice? Well, I call client.features. I can give a list of my features. So I have two. I have the average transaction on-demand percent. I can give parameters. Parameters are things that come at request time. For example, the transaction amount might come at request time. I can give entities. Entities are like the user ID in this case. These things together become the feature set. And so when I do client.features, this is actually getting pulled from Redis, and the on-demand feature is being processed at that moment in time. So it's truly real time. And then you can feed it into your model. Again, the model part, all that stuff, we purposely try not to be too hands-on. We just want to give you, here's an NumPy array. Here's the data frame. Like that's what we work with. That's what we want to give you. That's what we want you to use because we're not trying to break everything. What we're really just trying to do to finalize is fix this. Make it so that we're no longer dealing with untitled notebooks. Make it so we're no longer dealing with DF finals, feature store v7, running ad hoc Spark submits, not having any feature documentation, lineage, or anything. Make it so that every feature we build is very easy to toss over to deployment. Everything we build without having to change too much automatically is built in such a way where it's very easy to deploy for production. That was the goal. The goal is to do that and not completely destroy the data science workflow, which a lot of MLOps tools and I've used kind of do. They force me to like really not think and work like a data scientist anymore. Like I want to work in the notebook. That's how I've always worked. So trying to maintain that balance is what we've done. Be very lightweight while providing all the value of Feature Store. Any last, like I said, I'm going to send this over. I'll send over a notebook and a Terraform script so you can follow along. Everything I've shown you is actually in open source. So you could actually do this with our open source product. We will be at the conference. If anyone else, if you're coming, we'll be there. We'll be in pink. We're also hosting the happy hour on the first day, along with our friends at Aporia and Neptune. And then the second day, I'm giving another talk on a lightning talk about feature stores. Any final questions I can answer for anyone? And if we do run out of time, my email is simba@featureform.com. So if you have any questions, you want to chat, etc., you're not at the conference, or you don't run into me or anyone on my team, you can always just email me. Awesome. I hope this was useful, y'all. Hope to see you all tomorrow. I love MLOps World. It's always really a pleasure to come. So if you have any more questions, you want to get really into the weeds, you want to get into really in detail, let's do it. If you want to play around with Featureform, like I said, it's open source. Also, we're doing Hacktoberfest. It's getting towards the end of October. But if you want to sneak in some PRs for your resume, we're happy to help you do that. Awesome. Well, I'll stick around for the last 4 minutes. If anyone does have any last questions and they're shy, feel free to send them over. Otherwise, I don't want to keep you. I'll give you back a few more minutes of your time. Thanks, everyone. Awesome. Go ahead. say we have a model like a linear regression and we have scaled features. How can Featureform remember scaled features while predicting? Great question. I love that question. The way to do that is you put the scaling factor, you make the scaling factor a feature. In practice, most people lock in the scaling factor at the time of training, right? So you'll train the model, you'll lock in the scaling factor, and then you will serve that as a feature. And that actual scale operation where you divide, that will actually be an on-demand feature. It will actually look very similar to this, right? Like this client.features would be the scale factor. And then the parameter would be, it could be another feature, which would be whatever you're scaling, or it could be something that comes at request time. It's a great question. You could also make the scaling factor a streaming thing, but it can be risky because you really run into risk of drift because your scaling factor is changing, and then that means that anyway, there's like weird things that can happen. Your mileage may vary. What's ff.get run in that method? Great question. So everything in Featureform has a variant parameter. A variant is like a version. Even this has a variant. Like I could set the variant as test123. If I run this, right, you'll see it creates on-demand percent test123. Test123 is the variant. Now, by default, the variant is auto-generated unless you use ff.setRun, in which case that will become the default. So if I do set run this example, right, and then I kill the variant here, which would override it, and I run this, and I run this, you can see that the variant goes to example. It's just like a nice trick, especially if you're running a notebook and you want everything to have the same version, which is just a common thing we see. It's kind of like an experiment. So that's where people use set run. You can also look at our docs and you can go more into detail. So that's set run. Get run is just the opposite, which is you can just get the run. So in this case, yeah, you can just get the run. Could you share the notebook location? Like I said, we'll send this afterwards. I'll send it to the MLOps world people, and I'm sure they can send it to everyone. You can always join our Slack community or just email me, simba@featureform.com, and if you really want to make sure you get it, but I'll make sure to send it to the MLOps world people. How is on-demand features different from the pre-processing added into an ML pipeline from sklearn with a scaling transformation? It's actually almost the same thing. The difference is actually that it's not the only thing we do, right? Like in practice, most features, this is also a very great question. In practice, most features are actually streaming features and batch features, right? In practice, imagine you're Spotify and you're making a music recommendation. There might be like 200 features that goes into that model. Like the idea of taking every user's songs and listens that they've ever listened to and generating all those features every time they click a screen on Spotify just doesn't make sense. It's not possible. So in practice, right, they pre-process those features. Now there are times where you can't do that and you need an on-demand feature. So yes, what you're describing is true, but the problem is that there are so many pre-processed features, and sklearn doesn't really deal with Spark and Kafka and Flink and all these things, Redis. So we're kind of creating a single pane of glass across them. At the same time, things like Airflow don't really know what an on-demand feature is. So it's just kind of doing both and calling them both the same thing, monitoring them in the same way, naming them in the same way, allowing you to search them in the same way. That's the value. What is the idea? You are getting feature value from a specific run. Yeah, the run is like everything you build in Featureform is immutable, right? I'll show you. If I run this again, it will say ready, but it won't actually build anything because it knows that thing's there and immutable. If I edit it and I run it again, it will fail because it'll say, hey, like for example, if I let's do it like this. So I'll run this, I'll run it again. and then I'll run it with apply. And you'll see that it fails. This says that it's already defined in multiple places. That's because there can only be one true version of every feature variant. And so the version is the run. So set run might be a confusing name for it. But really the run is like the version. So it's like the default version. So really it's just like, what's the version of everything in this notebook? And typically people set the version to be something like the notebook's name in those situations. Awesome. I'll stick around for a little longer if anyone has any last questions. Thanks again for sending those questions. I knew there were people who had questions who were waiting. Awesome. And yeah, if you're around tomorrow, would love to see you in person if you're in Austin for the event. Um, but otherwise, thanks for coming. Yeah, I think I'm gonna head out this time, but thank you all. Again, I'm Simba at Featureform. Feel free to email me if you have any questions. You can always get me on LinkedIn too. There's not a lot of Simba Khadders, so easy to find.